Okay, welcome everybody to the grand finale of SQL Week. This week I've been posting videos and some content on LinkedIn and YouTube where I've gone through, in effect, a webinar that I do that introduces writing structured query language queries for new people, new to the world of data and new to the world of databases. And we've come to the last session, day 5. It's Friday lunchtime here at GRE Towers in the shed. Where we're making this last video for you. Now, I've called this out all week. Right, we are putting on a SQL Server training course at the end of February. It's a 3-day course where you will learn to write SQL queries from sort of start, and we'll build up to things like joins, which is what we're going to look at today. The costs, the dates, the links, the QR code that will take you to the website and contact details are found on there. If you want to check that out, feel free to do so. Just get in touch with me, DM me or whatever. If you're interested in the course, you're more than welcome to come on. Now, our week this week has been focused on writing SQL queries. We've been focused on the select statement. And what we've got on this slide here is the select statement syntax. Now, way back on Monday, we were looking at select from a particular table, and then we were looking at things like doing select star and then selecting a column list from a particular table. Then we moved on to doing things like filtering using a where clause, and we introduced the like condition in there so we could do sort of wildcard searches. We haven't looked at group by or having. Right, well, I might cover those in a future post, but they're not part of this week. We did look at order by, which is the this is what we need to use to order our result set. So in our select statement here, if we got select from our customer table, where date modified is between X date and Y date, and then we might want to order by customer name to get them in alphabetical order, or whatever the need is around that. We looked at order by as well. That would have been Wednesday. And then we've looked at joins yesterday, and we're going to continue to look at joins today, because yesterday we looked at inner joins, and inner joins is where, if you remember back to the start of the week, that might have a primary foreign key relationship between two tables, and we've been using customer and customer address this week. And it might be the customer ID from the customer table gets stored as a foreign key in the address table, so we can map and build that relationship between customers and addresses. And when you're entering an address, it would need to be allocated to a valid customer for it to work. Now, when we were doing our joins yesterday, we were looking for where there was a match on customer IDs, and where there was a match, the columns from those respective tables were brought back. Today, we're going to mix that up a little bit. I'll quickly, via the demo, I will show you left inner joins again, but then we look at left, right, and full outer joins too, just to finish off the week. So let me just drop off here and come across to my VM, which you can all see. So this is where we finished yesterday. We were writing an inner join, right, and it was joining on customer ID in the customer table, and also the customer ID in the sales order header, because we introduced the concept of table aliases yesterday to make our code look a little neater and easier to read. Now, if I run this, right, this is for a particular customer. Where there is a match on the customer ID, let me just use the right database. Where there's a match on customer ID, we get the customer title, first name and last name from the customer table, and the sales order ID. Actually, there's a customer ID from the sales order table as well, and the total due. Okay, so that's an inner join. Where there's a match, a row is included in our results. Now, coming back to this example, let's say we wanted to list all our customers, all of them, and any orders that they may have. That first query, that inner join, if there's no match on customer and order, that data is going to be excluded. All right, so what a left outer join will do, and I like to see if I can put this across one row, by using left outer join, we are specifying that the table here is the driving table. It's the most important table, the table to the left of the join clause. So this will return us all customers, and then where there is a match on sales order header, it'll give us results. If there's no match, the customer still included, but a null value will be returned for these columns here. Let's have a look at that in action, right? And it's exactly the same. Let me just escape out of that. It's exactly the same as before, right? We are excluding, or we're actually looking here for where sales order ID is null. Now, this is interesting. The reason I've got this on, let me do this without the where clause first of all, so you can see it working. All right, so this is without the where clause. You can see there, there's lots of null values in that result set. There we go, and we can find one where there is actually one included. So we have lots of customers that don't have any orders in this query. Right, where there is no match, nulls are returned, but where there is a match, the data is brought back. Right, now I can search for all the matches here if I wanted to, or I could search for all the ones that don't have an order. So this will return. What's that done there? That hasn't done anything, I don't think. Right, coming on to this next one, we're going to just invert this. All right, so that's the if I do this again, let's run that again now. All right, so we've got 815 rows returned, and it's excluded this time the ones with a valid row. So if you want to look for all, this is showing all customers, right, and the ones who don't have a valid order. Right, if you negated that and made it not, it would return. Made it is not null, it would return all customers with an order. But so would your join condition. Now, right outer join kind of works the same way. So if I bring this back to being on one row, we are now saying with this right outer join that the sales order table is the most important table. All right. Now, this is a bit of a contrived example because would you really have an order without a customer? I suspect not, right? But we're saying we want all orders, and if there's no match on customer, we still want the orders being brought back. All right. So if I do this, we're not excluding it because there's no customer. My customer ID is not null, so all our orders have a customer as we would expect. So that's just proving that for you. But it will do the same thing. So if there happened to be an order that didn't have a customer attached, that would actually invalidate referential integrity. You get errors if you try to do that with this database design, but it can be good for finding data quality issues. Then it will do that for you. And then the last type of outer join here is the full outer join, as you can see by this syntax here, full outer join. And this is saying we want all rows from both tables where there is a match, obviously match them up and return them, but otherwise include null values for those respectively. We know we've not got any sales orders without a customer. So it gives us 847 rows returned. Can't even read my own screen down here at the bottom here. Okay, so guys, that is the end of SQL Week. It's a little bit sad, but it's also a little bit challenging sometimes trying to produce content on a daily basis and get it out the door. But thank you for following along, for those that have been following along. Just a quick reminder, the course is running at the end of the month. If you want to get booked in, send me a DM, reach out, send me an email, whatever. It's all on the screen there. But thank you for listening. And no doubt I'll do a series of these again soon, but I think perhaps with a different topic in mind. But thanks for listening and enjoy your weekend, folks.